Kotlin Desktop, Lesson 18, System Integration. Today we build a system toolbox with clipboard monitoring, command execution, and platform detection. Here's the app we're building. A 3-tab toolbox with NavigationRail on the left. The Clipboard tab captures everything you copy and lets you click to copy it back. The command runner executes shell commands with output display. And the System Info tab shows your platform details and a filterable list of environment variables, plus tray notifications for every event. We start with a new Compose Desktop project called System Toolbox. The settings file sets our project name. The Gradle wrapper ensures everyone uses the same build tool version. Our build file uses Kotlin 2.1 and Compose 1.7.3. No extra dependencies needed. Everything we need comes from the JDK and Compose. Compose Desktop, Material 3, and Material Icons extended. The Compose block sets our main class. Source directory created. Now for our data models defines 3 data classes for our app. Clipboard entry holds copied text with a timestamp. Command result captures a command, its output, exit code, and execution time. System info gathers platform details using system.getProperty for OS info and system.getNV for the shell path. Three clean data classes. Simple and focused. Now the Clipboard monitor. This polls the system clipboard for changes using AWT Toolkit. We import Coroutine scope and dispatchers for background polling, plus AWT Clipboard classes, Toolkit, DataFlavor, and StringSelection. Start Clipboard monitoring launches a coroutine on dispatcher's I/O. It reads the current clipboard text, then loops with a delay, comparing each read against the last known value. When the text changes, it fires the callback. We use polling instead of FlavorListener because the listener is unreliable on macOS. It does not fire when same flavor content replaces existing clipboard data. Copy to clipboard is the reverse operation. It sets the system clipboard contents using StringSelection. About 40 lines for full clipboard, read and write support. Next, the command runner. This executes shell commands using ProcessBuilder. We import dispatchers with context and time unit for the timeout. Execute command is a suspend function that runs on dispatcher's I/O. ProcessBuilder takes /bin/sh-c and the command string. This lets us use pipes and redirects, just like a terminal. waitFor with a timeout prevents runaway processes. If the command does not finish in time, destroyForcibly kills it. Otherwise, we capture stdout, stderr, and the exit code. A clean coroutine wrapper around ProcessBuilder with proper timeout handling. Now the 3-tab composables, starting with Clipboard tab. We import clickable for card interaction, lazy column for the list, and material icons for copy and clear buttons. Clipboard tab shows a header row with a clear button that only appears when entries exist. Below that, either an empty state message or a lazy column of clipboard entries newest first. Each entry is tappable. Clicking copies that text back to the clipboard. Clipboard entry card displays the copied text, a timestamp, and a copy icon. The card uses surface variant color and clickable modifier for the copy-back interaction. Now, Command tab. The Command Execution Interface. Imports include key event handling for Enter key support and font family for monospace text. Command tab has an outlined text field with a run button. The text field handles Enter key via onPreview key event. While a command runs, a linear progress indicator shows activity. Past results stack in a lazy column. Notice single line true on the text field plus the Enter key handler. Single line alone does not block. Enter in Compose Desktop. The onPreview key event is essential. Command result card colors the card based on exit code. Green surface variant for success, red error container for failure. It shows the command, exit code, duration, and captured output. Finally, System tab, Platform Information and Environment Variables. Imports are straightforward. Material 3 components with the computer icon. System tab gathers system info once with remember. The environment variables use DeriveState.OF for efficient filtering. Only the filtered list recomputes when the search text changes. A platform card shows OS, architecture, Java version, user info, and shell. Below that, a filterable lazy column displays all environment variables with key value cards. Info row is a simple helper that puts a label on the left and a monospace value on the right. Three complete tab composables, each focused on its system integration feature. Now AppContent, the main layout with NavigationRail. This is a new component for our series. We import the three material icons for our tabs, plus notification and TrayState for desktop alerts. The tab enum maps each tab to a label and icon. Clipboard uses content paste, commands uses terminal, and system uses computer. AppContent manages all the shared state. Selected tab, clipboard entries, command results, and a running flag. Mutable state list of gives us reactive lists that trigger recomposition on add and remove. NavigationRail renders vertical tabs on the left. We loop through tab.entries and create a NavigationRail item for each. The when expression switches the content area on the right. Each tab connects to its handler. Clipboard gets copyback and clear callbacks. Commands launches a coroutine that executes the command and sends a tray notification with the exit code. Launched effect starts clipboard monitoring when the composable enters composition. Every new clipboard entry gets added to the list and triggers a tray notification. Now main, KT, the entry point with tray and window. We import Bitmap Painter and to compose image bitmap for the tray icon. The tray icon is a 32 by 32 buffered image drawn with Java 2D, purple rounded rectangle with a white S. This creates a proper system tray icon without needing an image file. The main function creates a tray state, renders the tray composable, and opens 1100 by 700 window with dark theme. AppContent receives the tray state, so any tab can send notifications. Let us review the complete file. Now let's compile and make sure everything builds. Here is the running app. The Clipboard tab shows pre-captured entries with timestamps. The navigation rail on the left switches between all three tabs. Switching to commands. We type echo hello and run it. The output appears instantly with the exit code and execution time. Running ls end date. Each result stacks in reverse order. Green cards for success, red for errors. Now System Info. The platform card shows OS version, architecture, Java details, and shell. Below, the environment variables list is filterable. Typing home filters the list to matching variables. Clearing the filter restores the full list. Back to Clipboard. A complete system toolbox in about 400 lines of Kotlin. Let us recap 5 key takeaways. First, Clipboard access. System Clipboard reads and writes using DataFlavor.stringFlavor. Second, polling. Coroutine polling with delay is more reliable than FlavorListener on macOS. Third, process execution. ProcessBuilder runs shell commands with a waitFor timeout. Fourth, notifications. The tray composable with send notification delivers desktop alerts. Fifth, platform detection. System.getProperty for OS info and getNV for environment variables. Thanks for watching. Like and subscribe for more Kotlin desktop tutorials.